let's see, today is the 7th, right?
Yes.
And then you'll be able to start the final next Thursday. Hey, Wolfie.
Hi.
All right, cool. That did come. All right. While we wait for a few more people, I wanted to show you guys a picture. We had a gig on Friday over at Temple of Music and Art. It's the Arizona Theater Company. So we played country music for about an hour. So that's Katie and me on our little setup. There's another picture. My wife took these. And there's another picture of our little gig. It was a good gig. We got paid $300, and then we made $55 in tips. So pretty good for 1 hour. So this is my suitcase, and it's a drum.
Yes, I saw the kickboard.
Yeah, but I don't use it anymore. It basically just holds all of our stuff.
Okay.
And then I have back here. It's called a stomp box, and I don't really use that anymore. I just have it. I built it, and it's got a microphone in it, and it's a piece of wood that's got an open bottom. And if I plug it in, I can actually stomp on it, and it gives like a bass. But I got something better, which you can't see. It's called a porch board, and it's back here, and I'm using that. Like when I don't have, this is my beat buddy. So this thing has beats, like whole drum loops for songs. It'll be like, and then I'll kick it. I can push on it, and it'll play the second part of the beat. So it's really good, and you can adjust the tempo and stuff. So whenever we have songs that have like a certain beat, I'll play that. But then if not, then I'll use the porch board if I'm just playing without a beat and just make my own beat. And I got a little mic, and this is we have a thing called Songbook Pro that has all of our songs on little Kindles, and it just scrolls the songs through so you can see it. She's got hers over here. And you can't see the speakers, but we've got two 2,000 watt Harbinger speakers out in front, and then a monitor speaker. There's a lot of crap to set up. It takes about a half hour to set up.
I know about that.
You know about that. So this is our gig on Friday.
Do you guys often do country music, or is this just a...
Pardon me?
Do you guys often do country music?
Yeah.
Yeah?
A lot of country. This was all country. Yeah. This was all country. So
Covers or your own stuff?
what's that?
Like covers or your own?
Cover.
Oh, okay.
Yeah. We do have our own stuff. Like if we have to play our own stuff, we've got about like 10 songs. Like she's written a lot of songs, and I've written like 4 or 5.
Yeah.
You're okay.
So the album's coming along.
Nah.
No, okay.
Nobody wants to hear your own stuff. They just want to hear covers of things.
You want to hear it though, right? So just
A couple of them I wrote I kind of like, but it's hard to write a song, man.
yeah, nuances.
A good
that
song.
are Technical.
A hit, like a world-class hit.
Yeah. We had a gig over at Monterey Court. It's been like 2 years ago, and it was for songwriters. And it was like weird. Like we were up there, and we'd play one song, and it had to be all originals. And then there was another guy on stage with us, and then he would play, and then another guy would play, and then we rotated through, like each play an original for like a whole hour. So we'd be sitting there watching while the next guy played, and then clapping, and then the next guy, and then we would play, and it was cool. It was cool. It's kind of they do it every so often, and they're trying to like introduce new artists here in Tucson, which is cool. But anyway, I just signed up. There's a thing on Thursday here at the Amethyst Room, and they wanted, it's an open mic, and so I signed up to do a song. It's this Thursday at 4 to 5:30. So I don't know what it is. It said you could do a little speech or say a poem or play music. And I think they're only giving you 3 minutes. But it's for faculty, student, and staff. So if any of you guys are talented and want to go join it, I'll be there playing. I think I'm going to do Chattahoochee. I'm pretty good at that one.
So open mic for like one song?
Probably one song.
Okay.
I think that's it. And I don't even know if it's amped or not. So, but the lead on Chattahoochee is pretty. If you've ever heard Chattahoochee, it's pretty tough lick to play. It's real fast. Anyway, I'll let you guys sign in here. All right, cool. And I don't have to leave right after class. I'm all done coaching now, so if anybody has any questions, I can hang around. So today is the 7th. Now we're going to get into object-oriented programming. Okay. Today and Thursday. Okay. And then next Tuesday and Thursday, I've got a few topics that I want to run by you guys. But for today, we're going to start into object-oriented programming. Now, what is due tonight? So you've got this Module 11 lab. So it's really 3 questions, 9.1, 2, and 3, out of your online book. Okay, so it's writing grades to a text file, reading grades from a text file, and writing student records to a CSV file. So you guys remember how we did that? We said with open counts.text as W, mode equals W, as accounts. Do you remember that kind of stuff? So you should have that in your notes. It shouldn't be all that difficult. And I also wrote all the answers. I created a 100-point quiz for the finals, and then I created a 14-question final coding exam. And I wrote all the solution myself last night. So I'm going to show you that sometime, like what it's going to look like when you run it. Okay. I don't think you're going to find it that difficult. It took me like an hour. Okay, so that's what's due tonight, those 3. And then what's due this Thursday, which is the 9th. Then we have the quiz, and that's on files and exceptions. And then we have the little brainstorm thing where you, it's not the interview, it's just answering some questions. And you can do that written, you don't have to do video if you don't want. Let me make this a little bigger. Okay, so I want to get a little feeling from you guys. So next week we're going to have 2 free class periods. Okay, so about 2 hours each. Hey. So these are some topics that I'm throwing out there. If you would like to go over those or something like that, you want to learn something new, okay? Something that's outside of what we're learning here. Okay. So the first thing is I could teach you guys a little bit about GIS and Python and what GIS is. And there's a free GIS software out there called QGIS. If you're interested in learning GIS, I mean, you can get jobs doing GIS work. I could teach you a little bit about C programming if you're interested. I could teach you a little about web programming using Linux, HTML, Perl, and Apache. So I could show you the back end of my database for track and field and kind of show you what it looks like and how things work in the back end using Linux and HTML and how some of that kind of stuff works. We could also look at some Unix basics and how to enable Linux on your Windows 10 machine. All you guys have, if you have a Windows 10 or 11 machine, Linux is available for you to turn on, and you would have a real Linux partition on your hard drive that you could run. You could You could run Python, you could compile C programs, stuff like that. I could teach you some SQL basics using MySQL, or we could review for the final quiz and the final coding exam. Okay. So just think about it. I'm just tossing these things out, and then maybe on Thursday this week, I'll try to get a consensus, see where we have like a democratic voting on what the majority thinks. Any of these things look interesting to anybody right now? Or?
Middle two and the last one. A lot of people
These
could
two here?
benefit from the second to last as well. If you're going to get into data analysis, it's one of the quickest things that we can do out of college or during college. So
Is
SQL.
SQL, yeah. Yeah, SQL's really good. Really good to learn, yeah. Yeah, we could go into some SQL basics. I could show you, well, if you have the free Office 365, you get access with that. I think you get Microsoft Access, which is a SQL server. That's a database. Microsoft Access is Microsoft's database. Okay, it's a pretty front end to what MySQL is. MySQL is not pretty; it's all command line stuff, but it's all the same. Yeah. Okay. Anybody else have any thoughts about anything, or anything jump out at you guys that you'd like to learn? Okay.
I think the maybe C programming or programming for the web is kind of interesting.
Kind of cool. Yeah. Yeah.
I guess the Linux thing is kind of interesting too, definitely.
Yeah. Yeah. This is not difficult. This one, just to enable Linux, we could probably do that on your machines in about 10 minutes in here, and you'd have it up and running, which is cool. Yeah, Linux is really nice, and if you guys want to do this third one here, then I will show you how to use a program called Telnet. If you've ever heard of that, or this one's not Telnet, it's Secure Shell, SSH. It's a way to get into a server, and it's all command line, and that's how I get into the server up on the web to do all the stuff that I do for the track database. So I'm in a command line little window, but it's called Secure Shell. So it's secure. It's like a VPN. It's encrypted, both sides. Okay. All right, cool. So anyway, there's a few ideas to think about, but for today and Thursday, we're kind of get into object-oriented programming a little bit, and I've got some good exercises for you. Let everybody in here. And object-oriented programming is actually really cool. And Python is really a good language to learn object-oriented programming, believe it or not. So what you need to do for this is read chapter 10.1 to 10.7 in the Dytel and Dytel. This is your online book. There's an interactive review slides looking at procedural and object-oriented programming. And then next Thursday, you need to do your interview questions, and these are the ones just to give you a heads up on what you're going to be learning. What is a class? Give an example. So we're going to, object-oriented programming is using classes, objects. There's a lot of words in object-oriented programming, so don't get confused. There's a lot of little new terms that you've probably never heard, like class, object, encapsulation, constructor, inheritance, superclass, subclass. Don't get confused. You'll understand what those mean once we go over, okay? And then the Module 12 lab, so this will be your last assignment before the final, is basically I've written up a Word document that's in pseudocode, and you're going to convert that pseudocode into Python. And it's basically going to be creating a pet, what we call a pet class. Okay? Alrighty. Okay, let's get up here. And we'll start looking into this a little bit. Come on. we go. All right, so what we've been learning so far, there's really two programming paradigms. There's procedural programming, which is what we've been learning so far, and now we're going to learn object-oriented programming. So the thing we've been doing so far is writing procedures, and procedures are like functions, right? We have a little function that goes and does something, and it jumps around, but basically it starts at the top of the program and goes down. Execution starts line by line, right? And it might hit a function, or it might get in a while loop and do some looping, or a for loop, but basically it's top to bottom, and it's doing procedures, okay? This was the first programming language, which meant that a program is made of one or more procedures. A procedure is a module or function that accomplishes a particular task. Okay, and we know functions are really supposed to do really one task. We might do a calculation, we might collect user data, we might prompt the user to say, please enter an integer, and we might do something with that, right? We might return the square of that, or we might return the area of a circle, or something like that, based on a radius. Well, this was our old book. So object-oriented programming, and they call it OOP or OOP. If you hear me say OOP or OOP, that stands for object-oriented programming. Okay. It's a term that refers to programming languages that use objects. Okay. Inheritance, data hiding, polymorphism, these are all some of these weird little terms you're going to hear that are all part of object-oriented programming. The main goal of OOP, or object-oriented programming, is to connect data and the functions that run on it so that no other part of the code can access it except for that function. Okay? So everything is an object. And an object, think of it as, well, this is a good analogy. Like, if you're going to build a house, right, you need a blueprint. You guys know what blueprints look like? Big pieces of paper, right? And they show you how to build a house, right? So I got a blueprint. And it's a piece of paper, and it's kind of in blue, and it might, might look like, it might say, okay, here, if this is a side view, here's my house, and that's 10 feet, from here to here, whatever. It has some dimensions and a roof, stuff like this. This is a blueprint. Okay, I've got to do that. And I've got a door right here, and I got a window right here, and this is 30 feet, whatever. So this would be like a blueprint. Okay, so this is telling you how to build a house, right? So with this blueprint, I can actually create a real house over here. Right? Or I could create a bunch of houses from the same blueprint, right? All the same. You guys have seen housing projects, right, where like all the houses kind of look the same? They've used the same blueprint, right? So you use the blueprint to create multiple houses. The same blueprint can be used to create a whole bunch of the same houses. So similar, we use a class to create objects. Okay? The class is like a blueprint. And with the same class, we can create multiple objects that are all the same. Okay? And objects, I have to go to this board now. An object is like, you can think of it as, this would be the encapsulation, where we're keeping all the fields in here. Like we might have something like, this is we'll call it a dog object. Okay? So we have a dog object. And what are some things what are some characteristics of a dog? What are things that dogs have?
Tails.
A tail? Okay. So we might have a field in here, this is the tail. So this would be a variable for the dog, okay? It's, all dogs have a tail, right? Usually. Well, some of them are kind of cut off, right? They're real small. But this would be like a variable inside this object. And we call the variables, we don't really call them variables in objects, we call them attributes or fields. Okay, what's another thing a dog has? Ears? Yeah. Ears. Okay, so this is another attribute. They have a tail, they have ears. Okay, what's another thing that could differentiate one dog from another? Like you have a dog and I
Snout
have a dog.
length.
Hmm?
Snout length of snout.
Yeah. Let's say snout. What about
Breed.
breed? That's a good one. Okay, we have breed. That would be an attribute. Okay. Okay, so now we've got a lot of things that all dogs have. What can a dog do now? What are things dogs can do? What are actions? Like verbs.
Bark.
Bark. Yep. Okay. Okay. So this, instead of an attribute, this would now be what we call a method. It's an action. Action verb, I guess you would call it. What else can a dog do other than barking? Dog next to me barks.
Bite.
Bite, yeah. Dogs can bite, of course, yeah. There's another method. Okay, that's a method. What else could be an attribute of a dog? Like, you've got a young dog, but I have a
Dog.
old dog. What would that attribute be called?
Age.
Age, yeah. So dogs could have an age. So this would be another field or an attribute. What else? What else would a dog, what kind of attribute would they have? They have an age, they have a breed.
Fur.
Fur, yeah, yeah, like long or short fur, yeah. Yeah.
Color.
Color, that's what I was looking
Yeah,
for.
this.
Yeah, color. So we got a lot of things. Okay, so these are all fields. And so we've got fields, which are attributes, and then we've got methods, which are action verbs, things that they can do, okay? So the thing about object-oriented programming, we've created a dog object. The idea of encapsulation is we're hiding all this stuff inside the dog object. And if we make, you can make these variables or attributes or fields, you can make them private or public. If you make them private, the rest of your program can't see this at all. Right?
What about the overlap between methods and attributes, like wagging their tail, like?
Yeah, wagging the tail, right? That's right. That's right. You can, yeah, you can definitely do that. Yeah, you could, yeah, have an action verb on one of the attributes. Yeah, yeah. Wagging tail, that's a good one. Okay, so this would be a method. So encapsulation is really hiding the data and attributes. Well, the data, this is really the data, or the fields, from the rest of the program. So it can't automatically or inadvertently be modified. Like suppose we've been writing our procedural scripts up until now, and we might have a variable up there called, what was it, like price of coffee, whatever, right? Coffee cost per cup. Somebody could accidentally, we didn't make it private or anything, it was like probably global, then it could be modified, you guys, it could be modified somewhere else in the program inadvertently by a programmer, and they might change that and mess up the whole program, right? So the whole thing about object-oriented programming is you're creating these objects, and if you make these private, you can make these little fields private, or you can make them public. Then the idea of encapsulation is they can't be modified. So it's keeping everything together. Like, I think about encapsulation, it kind of looks like the word capsule, right? Like, you know, like a pill is like a capsule, right? Like you might take a little vitamin pill, kind of looks like this, like a, I don't know, I'm not drawing that very well, but, and it might have a part there. So you take a pill that's gonna dissolve in your stomach, right? This is a capsule, everything's inside here, right? So that's kind of where they get the word encapsulation, putting everything inside of a capsule. Okay. Let's see. Okay. So here's some object-oriented concepts. This is from Geeks for Geeks. So we got classes, we got objects, we have data abstraction, encapsulation, we looked at that right now. Hide, that should be and objects data from the client code. We have inheritance, we'll look at that later if we get to it. Polymorphism, we'll look at that maybe today. A class is a data form that has been specified by the users, made up of data members and member functions. So these are the methods. Okay. Making a class case, it denotes a set of properties or methods that all objects of the same form share. A class is similar to an object's blueprint. Objects represent real-life entities, right? So an object should be a noun. Most objects we create should be nouns, like a dog, like a car, like an animal, okay? A tree, a door, a house, okay? So objects should be nouns. Okay, we're going to look at how to create one in a second. There's a lot, you got to just bear with all these words here. Okay, so this is, there's a lot of new words. We'll start learning them. So this is how you define a class, and I want you guys to try this. I want you to type this up in your, actually create a program, call it oop.py. Oops, let me let you guys know. I want you guys to try this. Admit all. Yeah, thanks for coming to class, guys. We're almost to the end. So create a program called oop.py and type in this right here. So this is how you create a class. So we're going to be creating an animal class. So you use the word class, space animal, and a colon. And then everything is indented in here. Okay? So a class definition begins with the keyword class, followed by the class's name and a colon. Okay? This line is called the class header. So this little line here is the class header. And then inside here, we're making our own functions, which are called methods in this case. But they're just like functions. Definition, show species, and then we put the word self in here. Okay? And so we're writing this would be a method, and then we have to indent again. Print, I am just a regular animal. And then we have another method here that says make sound. and we pass it the self argument. Self means itself. You got to use the word self in here for all these classes, referring to the animal itself. And it prints grr to the screen. Right. Let me scroll up a little bit more. So I want all you guys to try this. It shouldn't take that long to type it in. See if I can move this. Okay. See if I can-
Call it what again?
You could call it whatever you want, but I would say OOP.py. Okay, so here's your whole program right now. You're creating an animal class with 2 methods, and then underneath that, flush left.
Call it.
So now that we've created the class, now we create a variable called myAnimal equal animal with left and right parens. So we've created the class, now we've actually created the object. This is what takes up memory. This is called instantiating a class. So it's another word, instantiate. Instantiate a class. Does anybody know kind of what does instantiate kind of sound like?
Instant.
Instance, yeah. So it's creating an instance. Of the class. So remember the class, here we're defining the class. The class is the blueprint, right? This is showing us how to make an animal. And when we build a house, the house itself is an instantiation of the blueprint. That makes sense. This is an instance of the blueprint. So my animal is an instance of the animal class.
Is class an object, or is class part of an object?
Class is a blueprint that defines an object.
Okay.
So this isn't the object. This would be the blueprint. This, my animal, is the object.
Okay.
This takes up memory. This doesn't. Once you create an object, then that takes up memory. Okay? So we've just created an animal class, and now the animal has 2 different methods. And we invoke those methods with the dot. So we're doing a print statement. We're saying, here's info about an animal. And now we're saying myAnimal.showSpecies. We're calling this method. And then we're saying myAnimal.makeSound. So this is the way you call the methods on the animal object.
Object dot function.
Yeah. Dot function, but we call them methods in this case. But it's like a function.
Oh.
So it'd be almost like saying, if we were looking at a house here, we would almost say house, we'd say this is called house 1, and this is house 2. They're the same. They're both made from the same blueprint. And we could say house 1 dot open door. if we had something that would open the door on your house. Right? This door gets opened up. Oh, house 2 dot open door. I drew it on the wrong one. So this is kind of the same. These are the instances. Right? The instance of the blueprint. This is the instance of the class. Okay? So has anybody tried it? Did it work?
Just copying that?
Mhm.
Yes.
Does it print out?
Yes.
Cool. All right. Excellent. Good. Oh, okay. You did.
print statement for here is the
Anybody need
info
help?
about animals,
You guys get it?
but
Good.
I am just a regular animal as part of a function. Oh, did you call them at the end? My animal dot show species, my animal dot inside. I think that's technically calling it, but with the method. That might not be
Yeah,
technically
you'll see.
calling it, I don't know what I'm saying.
So that's the
Right,
way you
yeah,
refer to
Yeah.
itself, sort of. Yeah. Yeah, we're gonna write some more functions. We're gonna add on. This is the beginning. Gotcha. So the object. That's the object. Mhm.
And this is just.
That's the blueprint. Yeah, that's the
Did you say
blueprint
that's technically calling it?
for the animal. Good. So you following it? Understanding that so far?
It's after the definition, it's not the parentheses, it's just with the method.
Oh, get out of that.
Show.
Get out of your. Your internal components. Put that in there. This is. Yeah.
Okay, yeah, you define the method.
Good.
Yeah, that's why I said
Oh,
it's not a function,
left
it's a
and right
method.
for animal
Okay,
sound.
you define the method,
Yeah.
and we call it with.
Good. All right.
Cool.
Okay, you guys are getting this. It's really a cool concept. This is kind of the way programming is going now, is object-oriented programming. Java is object-oriented, C++ is object-oriented. A lot of languages are going the way of object-oriented programming. If you do any programming for your phones, like if you want to write apps and things like that for your phones, which is a big business too. I mean, you can make money for Apple too, especially. Everything is object-oriented, right? So if you understand this, it's going to help you out a lot. Okay, so we had a question about why do we have this self argument in here? Okay, so we're going to see that it's basically referring to, we need that to refer to the actual instance of the animal, of the class. So we're going to move on and we're going to modify this now. But I want to talk about a couple more things. Let's see if I can get it. Here we go. Okay. All right. So there's the idea of initializing a class object. So, and this is called __ init __. Okay. So it's called a constructor. So when you guys did over here, you said my animal. Equals animal, right? With this was creating an instance. This is instantiating a class or creating an instance of the class, and this is calling the constructor method. Behind the scenes, you didn't see this happening, but it did it. There's a default constructor automatically. You can create your own constructor, a custom constructor, okay? You have to name it __ init _, give it the self argument, and then you could say print, I am an animal, and then here's where this self comes in. Self.name equals gorilla, okay? So this would be whenever I created an animal, it was gonna, by default, become a gorilla if I make this my custom constructor, okay? And self.__ age is 13, so this animal has a name, an age, and a gender. Self._ gender is female. So we got a gorilla that's 13 years old and a female. So this is if you want to write your own custom constructor. But what are all these? Here it just says name. Here it's got 2 underscores and then age. And here it has 1 underscore in gender. What the heck do these underscores mean in front of our fields or attributes? Well, if there's no underscore, it means it's public. It means it can be accessed inside or outside the class. If I put 2 underscores before this field name, that makes it private, so nobody can see it. You can't see it from outside the class. So this makes it private. 1 underscore makes it protected. It can only be accessed within the package.
Is
Okay.
inside Python script part of the code?
This is, yeah, sorry, I made it too big. This should be over here. My line is just wrapping.
Ah,
There you go. I want to make it big enough so Richard can see it. I'll move it in the back. Now you probably can't, right?
Okay.
Okay, so these variables in object-oriented examples, public, protected, and private attributes or variables in an object, also called the object fields. 2 underscores in front before the variable makes it private. So this is the data hiding. This is how you can hide things from the rest of the program. Just put 2 underscores. 1 underscore makes it protected, and no underscores makes it public. Okay? So this is part of this encapsulation thing. So I could name this breed. I could name it underscore breed instead, and that would make breed private.
What do you mean when you said the variable is protected?
Protected means it can only be accessed within the package itself. Okay. There's modules that you can bring in. You can import. You can import packages too, or you could create a package. We haven't got into that yet, but this would be accessed within the package itself. So you could see it. You can modify it inside the Python script or the package, but not outside the package. So don't worry about it. We're probably only going to use public and private. Probably going to only use these 2. Okay, so I need to introduce another concept. Hey, Fernanda. I want to introduce a new concept to you guys, the idea of inheritance now. Okay, before I erase this, does everybody understand? I know Fernanda's getting here late, but so a blueprint is used to create houses. The blueprint is a piece of paper. It's not a house, it's just a piece of paper. It defines how you're going to build a house, what the height of the wall is going to be, and how many doors you have, and what's the pitch of this roof. And this pitch is different than this part, and how big is the window. And then when we actually use the blueprint to create a house, we're creating an instance of the house, okay? So the same thing with a class. When we define the class, that's the blueprint, and then we're creating objects from the class, which is like houses from the blueprint, okay? And this is called, these would be called an instance. The objects would be called an instance, or the process of creating this would be called instantiation, which kind of sounds like the word instance. It's got the word instance in it. We're instantiating a class, which creates an object. Just before I erase this other board. Okay, object, and then creating an instance of the class is another word. Okay. So right here, my animal equals animal. We're creating an instance. This is an instance. This is an object right here. So this is the object. or an instance of the animal class. Okay. Does that, anybody have questions about that? I know you came in late, but does that seem pretty clear so far? All right. So I need to erase this because we've got to cover inheritance now. Okay? Oh, I hate this. Let's try this. Yes, much better.
Oh, so.
Much better. Okay. All right, so we've got an animal. Okay, we've got an animal class that we created, right? So we have an animal. And we'll say this is the animal class. What other things are also animals? Is a dog an animal? Okay. We have a dog here. Okay. A dog is an animal. How about a cat? A cat's also an animal, right? So, and these are classes. So, this is the idea of inheritance. An animal is the top in this, what we're talking about today. This would be the top class that has everything. So we call this a superclass. Okay. This is a superclass or the base class. And what do you think these are called? If this is super, subclass. So a dog and a cat would be a subclass of the superclass. So this is the idea of inheritance. We can create new classes from the superclass that inherit everything from the superclass. Okay? So in this next exercise, so what did our animal have again? It had, I didn't write it here. What could our animal do again? It had a make sound, right? And then did it have anything else? What other definition did we have in there?
The show species.
Show species? Yeah. Okay. So this had two methods. So guess what? When we create a subclass from a superclass, it inherits these automatically. They automatically come with it. So now the dog has the show species. And the make sound method. Those get inherited. And so does the cat. These methods up here get inherited in. And make sound. Okay? So this is a subclass, or it's also could be called a derived class. It's derived from the superclass or the base class. And this is, and now I want you guys to do this. I want you to modify the script that you already have. And now we're going to create a dog class that inherits from animal. So this is how you do it. You say class dog, and inside parentheses, animal. Right? And in this show species, here you say, I am a dog, right? I think in the animal class, didn't it say, I am just an animal or something like
Yeah,
that?
I'm just a regular animal.
A regular animal, right. And what sound does a dog make? Woof woof. It doesn't, it's a little more specific now. Instead of just grr, it says woof woof, okay? So this is the idea of polymorphism. When you've got the same method in two different classes, you can use the same name, but this one can be different. It inherits it, and we could leave it the same, but we could change it, and then this one would say woof woof instead of grr. This one, when it says make sound, it just says grr. Oops, I'm pointing to the wrong thing. And then here's where we're creating a cat class. And this is our blueprint that inherits from animal also. Show species says, I am a cat, and a cat, the sound that cat makes is meow. So it makes a different sound. Okay? So type this in below where you've already set your other stuff, and then you can create a dog instance from the dog class, a cat instance from the cat, and then you could say, print, here is some info about dog, and you could say mydog.showSpecies, mydog.makeSound, and it should say I am a dog, and then woof woof, and you can do the same thing with my cat. So try that out, and that is the idea of inheritance. This is the beauty of object-oriented programming. You don't have to rewrite. If there's already a class out there, you don't need to rewrite the whole darn thing. You can just inherit from it, and then you can add your own stuff to it.
I like that. That's fun.
Yeah, so let me know, whoever gets that, put your hand up and I'll come and check it, see if it works. So you're just gonna add this to your OOP.py. Fernanda, you want me to email you OOP.py?
Yeah, please.
So you won't be out of it here, let's see. Sorry guys, I'll get right back to you. There we go. Right, whoop. Oh, I do have the cat one already. Let's see. Let's see if here's, okay, there. Okay, there you go. Whoops, that's it. Oh, you know what? I disconnected from the Wi-Fi. So now here. Oops. Yeah. I don't think it made it to you. There we go. Oh,
It's
it's
gonna be dots.
I think it's my Surfshark thing here. Messing me up. Darn it. Oh. See if that frees me up here. There we go. Sorry guys, were you still typing that? There we go. Okay. Yeah. Now I should be able to send that to you. There you go, guys. Okay, so type that in, let me see it, and then you guys can go take a little break. Got it? Okay, cool. Okay, and then there's a few more things up there that I added about it. So make a cat. Now make a cat object.
A cat object.
Yeah. Good. Excellent. Okay. Thank you. Good, yeah. So you following this? Scroll. Would you create this in your the same one that had the animal one? Is this the same thing? Okay.
Well, like, yes, but I.
Oh, okay, so you need the animal back, you can just put the animal back in. If you remember it, or do you, you can get it from, opening, right?
No, please.
You guys getting it? Okay.
Good.